Right, so back to this Mega Tracker CB1100. We've now got receive it to around 10 microvolts for 12 decibel SINAD, which of course is crummy, but I'm not going to take the receive any further. I got Mr. Chippy to change the MC3357, and I keep saying throughout this, a double-sided printed circuit board, and it's not a nice printed circuit board. Although it's fiberglass, the tracks are quite weak, and when I took the output transistor out, managed to break a track there despite all the correct techniques. So that's why we don't go any further. I'd rather have this working-ish than not working at all or ruined. So that's the thing we've got to do. I'm going to do on the air test with it. I don't know whether we'll get to scratchy corner on it, but I think what the customer's got is an interesting radio, a very unusual radio, and a nearly working radio. And that's better than a ruined radio or a totally broken one as it was as it came in. So the problem now is that when we were in transmit before, the radio went into the transistor went into thermal runaway. So what we're going to do is we're putting a complete new mounting kit on it, and there we go. Right, we'll turn this off and offer that up to there to make sure the pins actually fit. We did add a capacitor because on ours that capacitor's there, which isn't on his, and that did also improve the thing. Changing the MC357 was a major breakthrough because you could either set the detector to work really well at 100 microvolts, or if you went down to 10 microvolts, then you could reset it to work at 10 microvolts. But then if you gave it 100 microvolts, it was crummy. So there was some internal AGC problem. I was scratching my head over it. I said, well, I'll tell you what, Mr. Chippy, let's change the MC3357 just in case. And it's made light and day difference. So why is that failed? Because they're very, very reliable. But you just don't know what's happened to the set, do you? I mean, it's pretty immaculate. But the fact is that that filter was in backwards. Why? Right, so I've put that in. This is the damaged solder side. I've been able to sort that out. And I fitted a brand new mounting kit with a proper mica washer, lots of thermal heat compound. At this stage I've used a plastic nylon nut and bolt to see how much pressure we need. If it still starts with thermal runaway, then we may replace that with a metal one. But thermal runaway could be caused because I think the customers put this in for L10. Now if you look at mine for L10, L8 I'm talking about, we've got this, which is proper radio frequency choke. So what he's got there is a wire link with ferrite beads. So I think that's going to probably see as a short circuit and not be helping the issue. The other thing is that L10, which I erroneously mentioned before, is missing on this set, and L10 on here is a ferrite bead with 3 turns of wire around it. I'm not going to take this out because it's a double-sided board, and I'm going to end up with 2 broken sets, I can see, if I do that. So we can kind of guesstimate that. I don't think it's critical. So one of his ferrite beads, which he's put on there, will recover to turn into L10. Now L10 isn't shown on the circuit diagram. So on this production model, rather than the project version, you can see we've got L8, and L10 isn't. So there we go. And it's not, there's no space for it when you look. So we've got that resistor 45, but there's nothing, there's L9, but L10 isn't there. L8 is shown there. So, this is the problem. We've got 3/4 of the circuit information, but the production version is different. As I said, the VOGAD's here, but it's not on the project one. So I'm going to take this wire link out and hopefully we'll be in the right direction then. Of course I can't even find it now, can I? I think it's there. I'm alright with these, you know, 2 connection things, but if anything more than that, I'd have to take it across to the other workshop and deal with it with the desoldering machine. So hopefully we can lift that out. There we go. So that, yeah, that's fair enough. That would get it working, and somebody's put that in. It's not right. So what we're going to do, because we want, like in the picture, one of those. I looked at the circuit diagram for the Amstrad 900, which uses the Cybernet 002F chassis, and in an identical position. We've got, I think it's L8. So here's a genuine Mustang 3000, and I've said many times before, to buy this from a radio rally for £2 like this, which has been somebody's art project and been painted gold, smashed up, it's just beyond me. This is one of the best sets ever available. A £90 set. You don't see many. We had that fantastic boxed one from the customer, is in Cambridgeshire. Absolutely fantastic that was. We've got one on the shelf, so very sad. So one of these is going to be the right coil, but I've already forgotten what I saw on the circuit diagram. Oh well, that really helped this chassis, didn't it? You can see what killed this off. Somebody linked out the ballast resistor, and we've demonstrated that many times before. Instead of getting 4 watts, you get about 7 watts, but only 2 watts of it is on 27 megs, and the rest on aircraft band. So then the radio works really crummily, and then of course the transistor blows up. What a shame. Oh dear, right, so I'm hoping it's probably going to be that. And if it is or it isn't, that's the kind of coil we're looking for. Let's see what we've got on other chassis. I've got a AM Realistic here somewhere. Yes, this would have been a really nice set at one time had it been legal. Made by GRE for Radio Shack. It's got a 2SC2166 transistor in that, which is why we keep it. Well worth having. Look, it's even got its side bobbles. It's got an LC7131, which we could put in a CPT set. So it's got a filter. We've had some cores out of it. Really nice ones. But there you go, people import these illegal radios, and this is what has to happen to them. So, a similar position on this. would be that coil there. Why doesn't that want to come out? It did eventually. So once, to be honest, now this is nearer. I'm trying to find something which is pretty similar. We've got an AM max on, so again it is automatically scrapped because of that. So it has the same coil, but it's a bit weedier on that, so we're not going to take that one out. What's about this? That's not a scrap set. What about a grate? You've got it there. Anyway, I'll have a look through these and then I'll show you what we've come to. Right, so looking at a Uniden, in the case it was a realistic 2001 UK scrap set, we look at that, it's ever so similar, so we'll use that. So hopefully we can get one end to go in, and then I'll clean up this bit of wire and we'll solder that in accordingly. I'm just going to make sure I can get it in from the wrong side first. And I can. It's probably easiest to insert it that way. I think I lost it inside then. No, I hadn't. That was perfect. Right. So that's a like for like kind of part. In the same position on the circuit. So now we'll make, out of the ferrite beads that I've removed, we'll make a little choke with that. Right, well, a slight change of plan. I tried to use one of those ferrite beads, and unfortunately trying to make it a little bit wider with a drill carefully, and it snapped. So we're using one of mine instead, which is a Mollard FX1115, which are quite pricey these days. Like ridiculously pricey these days. I think I bought 10 for £16, you know, it was like that. So that is now an identical component to what's fitted. I've guessed the gauge of the wire, and I'm sure I'm right. This is enamelled copper, or it'll be polypropylene covered or something, so I've scraped away the insulation. So I'll just cut off that excess. And there you go. Sometimes you have to make a part. So that goes. Change his glasses. I would think this is to do with interference filtering, with it being on the production one rather than the project one. Right, what else is missing? Can we see anything else missing? Let's have a scan through. And this is why we have this business model of having one set of each ever made. Because then we've got some chance, but at least we've got the thing to start receiving, even if it's pretty crummy. Hopefully we've overcome the thermal runaway. Oh, I can't see anything else which is missing. So we'll do the scary thing. And see if we can find which microphone we were using. Did we? Oh, I'm totally at a loss now as to which mic it was. Was it Cybernet Standard? Right, power up. And we're going to transmit, and it's doing 4 watts. So if we can find the blue trimming tool, or even the green one. I haven't got the other cameras on, so I can't do picture in picture. That's a bit tight. Why is it tight? Not sure where the blue one's gone. So what I'm going to do, we'll just hold it in transmit for a number of seconds. It's doing 4.4 watts. I want it to be able to sustain it for 30 seconds without any degrading. solid. That's not going into thermal runaway. So I think the problem was that these coils were missing. So that's fixed up. I just need to, as I say, just make sure that's tuned up spot on. Yeah, right. So I've actually put about 90 minutes into this morning, doing that, researching what part we need to put in there, and actually implementing it and making that other part. So we should be in the right direction. Part of its thermal runaway could be that having just got that link of wire with the ferrite beads round it could have been seen as a short circuit to some degree, or over too much voltage into the transistor, and who knows what L10 does because it doesn't show on the circuit. But anyway, we've corrected what's missing. So we need to go through the tune-up procedure. I did the VCO, the synthesizer's all spot on, but it's the rest of it. Did I show you that this CFM2 filter, which we eventually tracked down, hours of research tracking these down, because there's no part number on it. It's only that I thought, oh, is it the same used in that PE Ranger? And the answer was yes. So in and out, and as I say, it was the wrong way around. So there you go. Perhaps it's always been the wrong way around. Perhaps it doesn't matter. But anyway, I've done what it's supposed to be. So, what have we got? Final part. Why haven't we got 2 pages? We've done all this, we've done all this. They want you to do receiver. Fine, they want you to do receiver. Let's get the layout. So there's the layout, except it needs to be that way on. So, tune the detector IFT we've got more sophisticated equipment than what they're expecting on this, so just let's think about this. We're not going to upset, no, we're not going to upset that. That's taken a lot of getting right. T3 we've done, maximum audio. First mixer, T2. So we've done that. That's been done on the test gear. RF bandpass filter, tune 1 and 5. That's those two. We've done that. And repeat for until they're expecting 0.3 microvolt sensitivity. We've got 10. So there's a problem, but it isn't going to be a straightforward problem. I'm not going around changing transistors and checking the gain because we're going to end up wrecking the set. Well, that hasn't actually, we've done all that. That hasn't actually done everything. Is it T8? Yeah. T8 is the one as the VCO's output. That one. So that's the final one, which we can now just trim Let's get the signal generator. For maximum. It's probably right, but having changed some parts since, we have gained a bit, and the other one, which is the front end, just trim that. So it's still 10 microvolts. So received down to about 4 microvolts. So we want to be absolutely sure that everything is as good as we're going to get. And then these, I think we've already ascertained we're not going to make any difference. Oh, I don't know. No, that's not right. Well, we can hear 3 microvolts on that. But it's very far from being right. There is something wrong in the IF. But we've gone from no receive to crappy receive, so there you go. So I'm just going to make sure we've got transmitted audio, because that was another of the faults, and then we'll do an on-the-air test. Wallow. Right, so Mr. Chippy has repaired the radio frequency choke, which is for the transmit. It's just near the, it's shown grey just there. It's the input choke for the audio from the microphone, and then there's this decoupling capacitor which I'll put back. It was the very first fault we found on this radio when it came in about 10 weeks ago. So, let's wait for the soldering iron to come on. And that will fix the no transmitted audio problem. So we've fixed the transmitter from thermal runaway, we've made a part, we've pinched a part out of a Uniden radio to substitute what should be there, so we've done the transmitter, doing the audio, we've changed this filter, that filter, that filter, the MC3357, I think we changed some capacitors in there, and the IF is still not right. I say the board on this, I just don't want to end up destroying the set. It doesn't matter if it's mine, but it does when it's somebody else's. So I've tested that we've got 455 kilohertz IF working what we think is properly. We've tested we've got 10.695, what we think is working properly. The sensitivity appears to be right, but it's deaf. But it's because of the IF. The FM hiss is just wrong. So it tells me it's the 455 part, but something's not right. Sometimes you've got to draw the line. Take the mic out. So that's soldered in position. And we have that wire goes on. Then that piece of sleeving, which isn't heat shrink, it's a rubber one. Then we look at my set and we see where the decoupling capacitor goes. It goes to where the other ones go. Except on this set, that's wrong. They've got the decoupling to power positive. It doesn't work like that. We've got another decoupling capacitor there, not going anywhere. So I'm sure if we solder that one to that one, then we need to introduce an earth. Now that's in the wrong position, folks. Hopefully. I mean, there should be an earth there, but just want the nearest point we can take it to. We take it to the body of the volume of the on-off volume control. Just check that is actually earth. We know that's going to be earth. That is. Just going to extend that bit of wire a little bit. There's a component lead there, that's ideal. You don't decouple things by putting it to the on-off switch. Trim that. And that's done the decoupling. A lot of little missing things. You just don't know what's happened to these things over the years, do you? Right. Time to power it back up. Let's see if we've now got transmitted audio. Volume control needs cleaning as well. Let's have a look on the... I say I haven't got the other cameras on, just bear with me. 1, 2. Right, we're going to do the deviation into the test set. I mean, that's stupidly loud, because the deviation will be very wrong. Testing 1, 2. It's so loud it's gone beyond the deviation which the radio can receive. Right, go over to the test set, but first of all, we'll just check which preset it is. I think there's only one preset in it. And I'll get the phone. Okay, so there's no deviation control as shown here. So I say there's quite a difference between the kit version and the whatever they are. They're all experimental, aren't they? It says VR5 is deviation, VR6 is clipping. Well, we haven't got VR5, and we've got VR6, and I've been able to adjust VR6 for 2.5 kilohertz peak deviation. Testing 1 2, testing 1 2. So at least we can hear ourselves now. Wallow. So that's that. So what other things have we got to adjust? We know the VCO is that. Whatever it says clipping is deviation is that. So it leaves us with VR1. I've got high-low power down there. I think we're doing 4 watts exactly. Doing a little bit over. I think one of those is power, isn't it? I'm going to have to read this yet again. So we're all tuned up, so that's happened. Transmitter lines full. We'll switch to full output. Set deviation with 5. We've done that. Clipping with 6. We've done that, and we haven't got the next page. We'll have to download the next page, I think. I think that preset is going to be power, because we're just slightly over. I'll see if I can switch the other camera system on. And put picture in picture on. There we go. So our deviation, oh, that's power. So you can see we're just over the 4 watts there. Go back to deviation. Wallow. I think it's reading a bit under, but that's my test set. Not playing ball today. So where are we? Power. Again, it just doesn't state, and this is another difference. I think we're at that one. It's not that one, is it? And is it that one, or is that the low power? If mine one, it's not connected. It might be on this customer's one. No idea why I can't get the tool in. That is the low. That is the high power one. We've set that to 4 watts. So the other one must be low power. So if it works on this set, yes, it does. That should be 400 milliwatts. It's a bit delicate, this one. 400 milliwatts, there we are. And then back to 4 watts. And it's 4 watts. Let's see what it is on the other channels. 3.9. 3.9, so that's well balanced. No overheating, no loss of power. Pleased about that. So we're going to have an RF power meter adjustment somewhere, I presume. When I key up, it's beyond what you'd expect. So what does it leave us with? I think I'm going to have to download the next page. I seem to have not got the final page. I must have known all this when I tuned mine up, but you know, there you go. Right, I'll be back when I've printed the next page off. Okay, so variable resistor 1 is the meter for transmit. So key up, it's now central to the red zone where I'd expect it to be. That's another one. So I'll make a note once again. Yeah, that was the part 2. It mentions no other presets. Get this the right way around. So TX meter. That's low power, because the other preset is high power. We've not got that on this version. So that leaves us with variable resistor 4. I can't see any others. And that must be the S meter, and it doesn't look like it has one for squelch. Right, I'll put S9 on receive. That's great, isn't it? Yeah, that is the S meter. That's full whack, I can't get any more. So that's very lazy because the set's deaf. Anyway, I'm going to pause it once again.
Can you hear me?
Right, so I'm just going to talk to you on the video in the next room. So testing 1 2 3 1 2 3 4 5.
Yeah, roger that. Testing 1 2 3 1 2 3 4 5.
Okay, it works for 20 yards then.
Very good.
Right, so in conclusion, we've got a set which is as deaf as a post, doing 7 microvolts for 12 decibel SINAD. Because of that, the squelch is abysmal, about 70 microvolts to open the squelch, because it has an IF problem which we can't get to the bottom of. So if we've got proper service information, instead of reading between the lines of a magazine project, which is kind of 2/3 of what this radio is, but this is different. My sample set and this differ. The transistors are different in the two sets. Wouldn't it be nice to change all the transistors that we think are... I can't test dual gate FETs. And, you know, you could, well, blanket change them, but they're between £5 and £15 each. So whatever we do, we lose money hand over fist. There's going to be no fee for this whatsoever, because I'm not, you know, we haven't actually got to the bottom of it, but we've done an awful lot. And the final thing we're doing is looking at our set, how the speaker's wired. We've got it between there and 21. Our blue wire's a bit too thick to go in these holes. I don't really want to drill the holes wider. 21 needs unclogging. So hopefully you all saw part 2. So this came in halfway through February, and I've now been ill for a couple of weeks, or well, 5 weeks to be honest, and it's still ongoing. So I certainly didn't feel like getting my head around something complex. So the bloke's going to get something back that transmits audio, it receives crapply, and it's better than having something which doesn't work at all. Perhaps with a preamp it will be usable. We're going to do an on-the-air test. Perhaps it'll work to the top of the hill, perhaps it won't. One. And again, you've got to have another set in front of you. But they're not the same version, you know. Obviously this was semi-experimental. How many did they make? Why was that filtering backwards? See, when we look at the service notes, and I've been comparing voltages in the receiver around the MC3357 to the effect that, or to the extent that I downloaded the data sheet for the MC3357 so I could work out what's going on. And there we are. But apart from the scan, I've got a different voltage on scan, but it hasn't got scan, so it really doesn't matter. What was I going to say? Oh yeah, this filter. You see, on this filter, I remember we've had to pinch one out of our pristine kit, and we're putting our filter in this cert. We're not recovering our filter because I don't want to be unsoldering things with the possibility of damage, so we're going to assume that the filter which was already in here was working. But it doesn't make my kit as pristine as it once was. I can order one of these from the States for £20. We've got in and out, and it was the opposite way round till it is in my set. My set's receiving at 0.4 of a microvolt, so mine can't be the wrong way round. So I've put it in the way it is in my set. So that's another move forwards. So we have come from a set which was receiving at 100 microvolts to a set that's receiving at 7 microvolts, and from a set that wasn't receiving at all, we've got the missing parts back in the transmitter. Mr. Chippy's repaired the choke there, which was causing there to be no transmitted audio. We fixed that. We've got it to receive. It's not exactly going to get us off as a desert island, is it? That'd be nice if it works for 3 miles. Even nicer if it did scratchy corner. And of course we had thermal runaway, you know, on transmit because of the way it was mounted had all failed on the output transistor. There we go, threaded that in. Well, I've got a wire from here to the front panel, but I haven't on my set. It's taken me ages to find the case halves, to be honest. Don't like sets which are long stayers. I'll probably put a stop to it, to be honest, as I've got to the age I am. We're not experimenters, it is supposed to be business. It's correct procedures to twist those. It's all about hum. hopefully. And there's been a lot of messing about, you know, on this. For example, there's a blob across the printed circuit there. There's a cut there which has been remade. Somebody's looked at this and kind of given up in the past, but we've looked at it, got it to do a lot more, but still given up. Needs an expert retiree who knows these backwards. The printed circuits, as I say, pretty weak. Four ohms surprises me. Right, let's see what happens now. Absolutely nothing. So that's wired to the wrong place on this set, but not on mine. You know. Pause the video. Okay, so I've got a duff switching contact within the 3.5mm socket there, which probably tells us why the 3.5mm socket is missing from mine, from the PA, because I expect somebody's had to swap it to use it for the extension speaker. So I've kind of cleaned it and bashed it a bit, and it works on internal and it's working on external. Well, it is today. So there we go. First lid on, wrong way round. First lid on, right way round. We've been over with isopropyl alcohol. Why aren't we soldered there? Yeah, we should be soldered just there. Turns the power off. So when I've remounted the output transistor, that's got missed. So it's done from both sides. It's kind of to be double sure. Power back on. Check it still transmits. It most certainly does. Got a capacitor there I haven't got on mine. We've not got a capacitor there which I have got on mine. So I've tried playing with both, and the sets are different. They've got their aftermarket, afterthought parts even. Can't remember whether it had any screws, but I'll tell you what, we'll put some in if they are M3s. And if they're self-tappers, well, that seems to be kind of holding. I'll just put a couple in each side for now. Yeah, as soon as I pick one up, lose it. So we'll never accept one of these for repair again. Right, time to plug our aerial in, which we're not going to hear anything. Not with 7 microvolts of sensitivity. That said, I can hear like 1 microvolt on it. One Anna, Roger. Well, there you go. So the CB1100 Mega Tracker from 1982 that we haven't been able to fix.